Hi there, this is your announcer, and you're about to watch an exciting first episode of The Joy of Functional Game Dev from your heart to the screen with your host, Ernest Pizzera. Since this is the first episode, he could not find anybody else to do his announcing for him, so he's doing it himself. Now here's your host, Ernest Pizzera, who's also me. Thank you so much, Mr. Announcer, who is also me. And welcome to the first episode of The Joy of Functional Game Dev. And the way that we can work on that work with this is the start of every episode and the end. Start of one episode, end of another episode. I'm going to put a GitHub release on the project. I've got a repository. The links and everything will be down below. And you can go ahead and go to it, get the source code, and that's where we're starting from. Right now there is nothing. There's no source code. There's a README file. That's about it. But so, the agenda here is to follow along with one game a month. And so let's take a look at the one game a month January keynote. Link for that YouTube video also down below. But we'll just kind of get the gist of it. So, okay, welcome to this. There's the optional theme achievement word is hobby. And okay, so that's cool and interesting. And it goes on to make a point about how, hey, if you're chasing becoming a pro, the idea here is watching industry trends the last few years, you can see that indie game development is as viable a career as being a poet, musician, artist, or writer. A dream job, not impossible, but for most a hobby. So that's the whole, alright, why are we chasing money and monetization and all this other stuff? Why did we get into games in the first place? Why do we like to do that? And he's absolutely right. And it's something that I've struggled with because I've had a day job for a very long time now and doing little games on the side. Not getting any success really monetarily because I can't dedicate the resources to it because I need to provide for my household. But so, alright, so that's our theme, and our achievement word is hobby. And so let's take a look and think about how we can kind of what we want to do to make a game. And we're going to do it using F#. So let's close this out, and here we are in Visual Studio. I have Enterprise, but Express will work just as well. I'm going to make myself a console. We're going to start with a console application, but instead I'm going to browse to, no, not there, F#. So here we are, project 1. And as you can see, there's nothing but a Git here. So we're going to select this folder. And it's not going to be called console application 1. We shall just simply call it, for now, project 1. And while we're, I've actually got a name. I've got a name for the game, and it's called Moneyface. And we will make a directory for the solution also called Moneyface. We'll call it Moneyface game. Moneyface is Moneyface. Just leave it. We'll deal with all this, all that later. So alright. And we wind up with, of course, the boilerplate F# code. And so what do we want to do in Moneyface? We're going to start as a console app, and we're going to use the console manipulation functions, which we'll take a look at in just a second. But so the hero, or at least your avatar, is a smiley face. and that's U0002. It's a time attack game, 60-second timer to do whatever it is we're going to do. The goal is to get points, and those points are dollar signs, so we're chasing after money. And so that in itself could be a game. Here you are, you're a smiley face. You use the arrow keys to control your smiley face to go around the screen collecting dollars, and the more you can collect in 60 seconds, the faster you are, the better you are. But that's not enough. That's not enough in the theme. So what we're going to do is we're going to add a wrinkle. Wrinkle is you have to manage your mood. And in managing your mood, you must, there will be a heart. That's, I believe, 003 is the heart. Will put you in a good mood. Put this on down here. Alright. Heart will put you in a good mood. Good mood means you move faster. Bad mood means you move slower. And so, but the thing is okay, so hearts will generate on the screen, dollar signs will generate on the screen. But in each case you'll have to guess. However, hearts cost money. So the heart represents your hobby. That's the thing that you're passionate for. And the dollar sign represents you have to go out there and fund your passions. And so this kind of really just has so Moneyface is the character's name is always Tag On, but whatever. So in Moneyface, the whole point is I have to get money in order to feed my passion, but I have to spend money on my passion, but I need to do the thing I'm passionate about in order to keep going at a decent enough rate. And we'll put as a stretch here, must sleep, or you will also slow down. And we're going to represent must rest. We'll call it rest because you're not actually going to sleep. Must rest. Rest is represented by a Z. So, cool, right? Alright. So that's the game design in a nutshell, and our backstory is we want to pursue our passion, and we have our life, which is short. It's only 60 seconds. Get as much money as you can. And I think also rest will increase the timer? Maybe not. We'll think about it, and then it periodically. So you'll have a couple things to manage. All right. So cool. So at the moment, this doesn't do a whole lot. If you, as a matter of fact, you need to, in order for you to even see anything. So we're going to open system, console.readKey, and we have to ignore that because read key will return something. The read key, and I ignore. So in order to even really see something of the boilerplate, you have to say, hey, what are we doing? That's where is it going to pop up. and nothing. So there's the argv array. It is an array with nothing, and the array symbol being see if I can keep this defaults. I think I want that there. So now if I run it again, because what I'd really like is, okay, cool. So I'm in the console, but I want to be able to see it if you're watching it on a Roku or an Amazon Fire TV, and so I need a bigger font. So now every single time I run it, it's going to be in this 28-point font. So I like it. So and here we are doing some nothing. So what I want to do though is I want to limit the size of the console. So I want to initialize the console, and it doesn't take anything, so it takes unit. Initialize console equals, at the moment it does some nothing. But what we want to do, and we may wind up having, yes sir, we are likely to have to go to console.window width. We wind up looking up some stuff on console today, and I think maybe we'll get ourselves to the point of getting that cell. That's, I'm not a complete fan of the ... thing that Microsoft is doing in the MSDN documentation. So I got window. Ugh, stop it. Got window width. Thanks everybody. Window width, window height, and then there's also a buffer width and a buffer height. And as I think I recall from times before, so let's print these things. Console.WriteLine, console.window width, and we will do all these stats to see what we start with. That's going to be buffer, and buffer height. And let's see what it spits out. So it's 80, 25, 80, 300. So I want to constrain my screen so that I only have 25 by 25. I'm going to limit it to, so my play area can be 30 by 25. Does that seem reasonable? Or 25 by 25. And you know what? We'll spill it over to 40 by 25 so that I have something on the side where I can put some text and keep track of where we're at for the how much time we have left and what our score is and our other stats. So that's cool. We'll do that. And in order to do that, we need to, these things are mutable, so we're going to tuck a 40 into there. Not a beer. That's, and we're gonna, since it's the same value, we'll just read it off of there. And these, I no longer have to return a unit because that stuff already, an assignment operator already returns the unit. Do we set it up? Did I do it right? Okay, cool. Alright, so I've got a 40 by 25. What I do need though is that kind of sucks. I just want to quickly go console title equals money face, and that's a thing saying we like to split content up a little bit here on the joy of functional game development. And now we're going to get to a little segment where we can take a look specifically at the functional programming concept of the day. And I'll see you right back after that. Today's functional programming concept of the day, since it's our first episode, is function. A lot of people think they know what they mean when they mean function, and we're going to take a look at a couple of different perspectives on it. Here at the Joy of Functional Game Dev, I have a particular take on it that I think really simplifies all of the gobbledygook that others say. So first, let's look at the mathematical definition. And for any sort of mathematical academic thing, I like to engage in a character which I call the Ukrainian professor. And he sounds something like this. A function can be defined by any mathematical condition relating its argument or input value into the corresponding output value. If the domain is finite, a function f may be defined by simply tabulating all the arguments x and their corresponding function values f of x. I don't know about you, but this doesn't help me much, and there's the Wikipedia citation right there. You can go check that out if you want. And very nice ovals and x's and y's and lines going. And we did a lot of this. If you've been through algebra, this is something that we've gone through a lot. That you've probably gone through and seen something like this. But defining what a function is this is too complex of a definition. So we'll go with the MSDN definition, and for that I have to go with more of the hipster nerd developer who says things like, well, technically, functions are the fundamental units of program execution in any programming language. As in other languages, an F-sharp function has a name, can have parameters, and take arguments, and has a body. F-sharp also supports functional programming constructs, such as treating functions as values, using unnamed functions and expressions, composition of functions to form new functions, queried functions, and the implicit definition of functions by way of the partial application of function arguments. I don't know about you with this definition, and there's the citation for MSDN right there. You can go look that up. That's the first thing it says, or at least when I looked it up. And there's lots of words, and function this and function. A function is defined in the forms of function itself. It avoids defining it. We're going to go a little bit simpler. Here's the joy of functional game dev definition of a function. A function is a thing that takes a thing and makes a thing. Well, we'll say it again before we're done. But so a function is a thing that takes a thing and makes a thing. Okay, all right, you can get behind that? Cool. Now let's talk about things. So here's thing. So things, a number, a string. And in C# we've got things. We've got variables where we say int I is being the thing, and it has the value of 10. And the string s, which has the value of name. In F# things, they're not variables. They are values, and let I equal 10, let s equal 10. Equal doesn't mean the same thing. Equal means whenever you see I, it means 10. Forever. And we'll get to that another time. So, but what the main concept here is a function is a thing. And so most of the time we think of function as being behavior. So let's take a look at C# function, the increment function that takes value and returns value plus 1. In C#, the increment function has a type. It is a template. It is a generic type func int, where the first one is the value of the parameter, and the second one is the return value. In F sharp, we use let to define this. So we say increment value equals value plus 1. We don't put int anywhere, but it knows, because of type inference, because we used a 1 and 1's an int, so therefore value must be something that I can add an int to, and the only thing I can add an int to is another int. And so it now knows, alright, so I infer that value is an int, and that it's going to return value plus 1, which will also be an int, because anytime I add 1 to a value, it will be an int. Okay, so, and it takes a thing, and here I have highlighted in green in C sharp and in F sharp, value, which is a thing, some value, the function accepts it. And it makes a thing. In the case of C sharp, you have that's what it returns, and that's the type. And here in the F sharp function, that's what you will get out anytime you call increment. You'll get whatever the value is plus 1. However, since a function is a thing, and a function takes a thing and makes a thing, does that mean that a function can take a function and make a function? Absolutely. And that's the power of functional programming, really. So here we are. If you don't believe me, this code I put in the F sharp project console application and checked that yes, indeed, as written here, it does work. So I let increment be a function that are the same example, the value that takes value, adds 1, and gives you that new value. Now, next one, I'm going to say twice. Twice takes one function called behavior and returns behavior, this operator behavior. That is the composition operator, which is basically a plus sign for functions. It takes whatever the first function spits out and puts it directly into the next one, so that you can really just consider it all one function. And so I said, okay, cool. So I've got increment and I've got twice. I'm going to make something called increment twice, where I'm going to send increment to twice, and now we've got a new function, takes an int and returns an int. And if I take value of 0, so I let my value be 0, and then I pipe value into increment twice, I will get a result of 2. You could take this code and check it yourself in F sharp interactive, whatever you want to do. But this indeed does work. So okay, great, I can increment and I can double increment. Now how about you find examples from functional programming. F and G are functions and so on and so forth. So increment, not terribly interesting, but let's do something that's more game related. And you'll have to trust me that there's a location record that has an X and a Y. And this is so I have a move north function where I take the location, I leave the X alone, and I have location plus 1. So the positive Y is to the north. I have another one that says move east, so Y is left alone, and the location.x plus 1 is the new value of X. And I can take those two and move north, composition operator move east, and it will then I can say X equals 0, Y equals 0, and it'll spit out a brand new value, whereas though I've called that, then called that. And how awesome is that? So I've got a brand new function, but I just cobbled together two functions, so I don't have to copy pasta. I don't have to bring those things over. And it's way less code than if you wanted to do the same thing in C sharp. And finally, one more reminder. A function is a thing that takes a thing and makes a thing. And now we're back to working to get the Money Phase app started. And we can immediately see here a blue squiggle that indicates that today I coded too much C sharp and have forgotten that equal does not mean assignment. So here I did it just fine. The little arrow pointing to the left is the assignment operator, and that works for money face. So I wonder, can I do this? Slash 002. Will that work, or will it just look weird? Well, let's find out. So in any case, here's the money face. Yeah, it doesn't show it. But we can do money face as a emoticon. Why not? Yay, money face. Alright. We don't need you anymore. You we don't need. We've initialized the council. We did that. We're going to need some sort of... sadly, in... The whole point of functional game development is to try to be as immutable as possible. But in reality, at some point you have to persist your values somewhere. That might be to a file, that might be to a database. In our case, we have to have a game state. So we're going to type game state. I'm going to go with a play state here, because, well, board state. And it's a record type where we have player, which will have an X and a Y. And we'll just use int tuples for that. We always have a there will always be a dollar sign on the board, so dollar, which will also have an int. We need a score. Int. We're going to start with just, hey, let's make a thing where I wander around the screen and I collect dollars. Let's get that done, and then we'll add the other things. So let's start small, build up, shall we? And so so I need a player. I need to keep track of where he's going, what he's doing, and we need a dollar, and we need a score. So that's great. But we also need, unfortunately, to persist that in between calls. And so we're not going to be able to be immutable. We have to be mutable on some level. And we're not going to store in a database. It's a small amount of data. So though the functional programmers now watching are about to cringe, I'm going to say let mutable board state equals player 00 equal. Now it's equal dollar equal. Let's call it 10 score. Dollar 10 score, a score of 0. So we've got a mutable board state, but I want to kind of hide it to a large extent. So what I want to do here is I want to have a let load board state equal, and it's just going to pull out the board state. Let save board state take a new board state, and we're going to say board state new board state. Cool, and you're like, well, why are we doing that? Why can't you just leave the thing and just persist it and whatever? And the answer to that is, I'm about to make a module. The thing we're going to do is we're going to have board state. And we're going to remember immediately to put it up there. We're going to take board state, kill those guys off, and say, hey, type board state. Is this where the private goes? Let private mutable. So is it mutable private? Private. Okay, so that's now hidden here. So we can replace it later if we wanted to stick a database on the other end of it. We want to stick a file where we send it out to. And so that's exactly how we want to do that. And then really I want the so alright, let's render the board state. Let render board state equals, and it's going to do some nothing. We're going to open board state, because sometimes you just got to get stuff going. So let's say we're just going to render the board state. We're going to gather input. And that's what we are going to do. Yeah, so we're going to render the board. So the first thing we're going to do is we're just going to render the board state. We're going to load board state. We're going to send it to render board state. And when we render the board state, so I'm not even sure if it's a zeros based or one based. We're going to find out in a hurry. First thing we want to do is console dot foreground color, console dot cursor left. We'll store board state. Let's strongly type it, shall we? Board state, which is a board state. What do we call it there? We call it the player. So let player X, player Y equal board state dot player. We're going to console.cursor left. We're going to set that to player X. Console.cursor top. Player Y. And console.right. /U002. And similarly, we're going to let $x $y equal board state dot dollar. Cursor left. $x. Console dot cursor top. $y. Console.right. That's $1, so make it $1. And let us see what happens when it does, this one does not have a raster font. Okay. What other font? Alright, let's see the Council 24. So that's a well, that's disappointing. I've been on other consoles where it did allow me to what consolas? Nope, that's a thing. All right, we're not going to use an actual smiley face. Then we're going to use the @ symbol, and that's totally and perfectly okay. Use the @ symbol because if we can't get a smiley face out of here, we're going to use an @ So there's the @ 00, and there's the $sign there. I've got a cursor visible, which I don't like. So in my Initialize console, cursor visible should be false. So then I should not be able to see that anymore. So there's that. Now I need to be able to move him around. But unfortunately, I need a little bit more than my than what I'm doing here. I need another. For now, I'm just going to do it this way. Going to have sort of a game state. So we're going to say type game state equals. This is going to be a discriminated union. We're going to play. We're going to quit. And we need to let mutable game state equals play. And when we we're actually going to render game state, let render game state equals, we'll have to do nothing. Initialize the console, and we're going to do a while game state not equal. Forget the not equal. I don't use the not equal very much. Let's look at the F# not equal. F# not equal. What is the F# syntax for not equal? It is not. Let's enter greater than. So, okay, like SQL then. Game state not equal to quit. Board state, render board state. Board state. Render board state, and then I want to process input, and then I want to save board state is what I want to do. But at the moment, render board state does not return anything. We're going to have it return board state so we can pipe it through. Did it do? Don't use a lot of whiles in here either. Do process input. And we're going to say, so render game state process input, let process input the board state equals, and it's going to be a board state. Again, it's going to return that, so it's going to do nothing. And yeah, this is a mess at this point, but we're gonna get somewhere. We're gonna get somewhere very quickly here, and we're almost to the point. So this is our loop. While I'm not quitting, do load the board state, render the board state, process any input, and then save the board state. And this is exactly the sort of functional pipe it through that you want to be doing. It's what it's all set up for. And speaking of, that's the worst segue ever. Hey, speaking of F# core components, here is a little bit on the F# core component of the day, which I'm actually highlighting here. Well, at least it's in the little tooltip. So I'll see you in just a little bit. Today's F# core component of the day is unit. Unit is not, the concept behind unit is not unique to F#. C# has and C# and many of the languages like C# have a similar idea, which is void, which really means nothing. But as we shall see, it's nothing, and yet it's not. So let's explore a little further. And okay, so the MSDN definition, and here's the citation down here so you can look it up yourself. The unit type is a type that indicates the absence of a specific value. The unit type has only a single value which acts as a placeholder when no other value exists or is needed. Did that help? Yeah, not really. Me neither. Okay, cool. Let's look at our definition, where unit is a type, and we like types, that holds a thing. Okay, things, we know what things are, and that thing is nothing. I'm going to say it again because it's a little weird. Unit is a type that holds a thing, and that thing is nothing. Okay, let's take a look. How can nothing be a thing? Since a function is a thing that takes a thing and makes a thing, because we looked at that before, and there are plenty of times when we need to write a function that doesn't take anything. We have no parameters to send to it. We'd go load from the default file. Who knows? Or you may need to write a function that doesn't make anything, makes nothing. For example, something that renders audio, or something that starts playing a sound. It doesn't return anything. You might return a status. You might not. You might not care. So it may return nothing. So in order to have a function that takes nothing or makes nothing, because functions are things that take things and make things, nothing must be a thing. All right. Ready for more? It's awesome. Okay. So here's a function called takeNothing that takes, and if you put this in F# interactive, takeNothing with this, it will have a type of unit int, and you can call it and it'll return an int every single time. But if you don't put the little braces right there, it's just a value. It's just an int. So the little two braces together is nothing. But there's parentheses, so there must obviously be a thing. And in C#, it looks very similar. In things like C, you can actually put void in there. But so right at this point, nothing in C# looks the same as F#. So making the thing that is nothing. So I'm going to take a value and I'm going to do nothing with it. I'm going to return nothing. Why am I doing that? Typically there will be something else that you do with X in between now and but you just have no value of returning. And if This function has a type of apostrophe A, so it's a generic type. It's like, I don't know, it could be anything. Could be horses, could be jack-o'-lanterns, who knows. And so you take jack-o'-lanterns and you create units out of them. And until at some point it'll infer a better type for it. So, taking nothing looks like open close, and making nothing looks like open close. And this is the big thing. The parentheses are around the nothing. The parentheses just section off the nothing and are not themselves the nothing. The nothing is between the parentheses, and the parentheses have to be there in order for us to know that the nothing is really there. And when we make nothing in C#, we have just a void and we have return. And the nothing is in between the n and the semicolon. So, isn't that a cool thing? Alright. We have plenty of common functions in F# core that take nothing, all of the empty ones, because it's like, hey, give me an empty set, give me an empty map, give me an empty sequence. And then lots of times when we have to talk with imperative code, there's console clear, console readline. We'll be using those. We will use those in early console projects. And functions that make nothing, anything that iterates through a collection. So map.iter, seek.iter, and list.iter. And again, many times when we have to interface with imperative code, clear both takes nothing and returns nothing. So takes a unit, returns a unit. So unit to unit. And finally, after a while, you will have this. I get this error all the time. I'm in there inserting code, and here's the thing. This expression should have type unit, but has type doesn't matter. Use ignore to discard the result of this expression, or let to bind the result to a name. So you either want to say, hey, keep this value around as a let binding, or you want to say, there's an int here, or a string, but I don't care to do anything with it, so ignore. Luckily, this error message does tell you exactly what to do. You use ignore, and you almost always fix it with pipe it forward into ignore, and then your day is done. And so finally, unit is a type that holds a thing, and that thing is nothing. Well, that was a lot about nothing, huh? So next, we're taking a look. I don't need to render game state yet. I don't want to put code that I know I don't need yet. And at any point, we're going to tuck that. So in process input, the thing that I'm going to do is from the console key available. All right, so I want to read a key. I'm going to read a key. So let read key, which takes nothing, is so if console.key available, then else none. Some console.read key, and I want the one where I want the intercept. It's true to not this, so true if I want to hide the character so I can read these things in. Alright, can't really tell what dot key, just want the key, some. So I read a key, so if there's a key available, then I read the key, I don't echo it to the keyboard, I take the console key value and I put it on some, otherwise I get a none. So, cool, and that allows me to match read key with By default, we're going to do some nothing. So we are going to do this. Let delta x delta y. I have not started my timer, so we're likely to run a little long. Let's get equal. So if it's some nothing, then put 0, 0. Anything out of the ordinary. So if there is a read key, yeah, no kidding, incomplete pattern matches. Key dot, so some key dot console keys. Oh my goodness, read key, the console key info. So it's console key dot up arrow. Oh, okay. And we're leaving it at 0, 0 because we're about to change some stuff. Down arrow, left arrow, right arrow. Now the top of the screen is in a negative direction, so we're going to do -1 here, +1 here, left -1, 1. Alright, so now we got a delta x delta y. And we're going to want okay, so that's how we're going to do it. Alright, board state with player equal, so we start with board state dot player it's first, and board state dot player, it's, I believe, snd. Yeah, this is a weird one. So in a tuple, because these are tuples, I have a first and a second. First is FST and second is SND. We just nod our heads and say, all right, that makes the most sense. Sure, first and second, you got it. Plus delta x and plus delta y. So not the greatest thing in the world, but let's see what happens here. I think I'll be writing the character to multiple parts of the screen. Ooh, and that's blinky, and it leaves. Yeah, that's awful. Well, that's fun. So if I have nothing, yeah, that's super bad. But that's the nature of the console. So what I really want to do, and I need to backtrack the last position. Oh my goodness. So I need also, that's awful. Okay. Well, let's be super duper blinky and let's console.clear. Console.clear. And we'll be very, very blinky, but we'll live. Alright. That's horrible. I don't even know if you can see that on a video. or if the 30 frames per second render is even going to register that. So pretty much immediately, that's super duper awful. And so immediately I want a better way of rendering. But how, you ask? And I think we'll have to get a little clever about it. But for now, okay, so he can move on to there, but so what? And we've got a little bit of time, and really, let's have, put under board state, open system, let random equals new random. And then I also want let board columns equal 25. Let board rows equals 25. And we're also going to have a let random board position the next board columns random.next. Now typically anytime I use random, somebody's going to point out, hey, random is not a good choice for blah blah blah. It's not sufficiently random, it's pseudo-random. And I'm just going to tell you, for the purposes of this application, for the purposes of this game, random is random enough. So, quiet you. I think for initializing this, we're going to give him a random board position. And let's see how we do. So now we're at a random position. Yep, there we are. Okay, we move around. And this is horrible and atrocious. And we're gonna, maybe if we require a little bit of sleep in between the system.threading.sleep, render board, we're gonna do it system.threading.sleep thread. Alright, where's sleep? Thread.sleep. Thread.sleep method, which is in system.threading. Now, so system.threading.thread.sleep. Shows how often I use this. We'll just open system.threading. Open system.threading. We'll just thread.sleep. 100? That puts us at 10. 25. Let's do it. Already quite a bit more. Still a little blinky. Alright. Put it at 50 just so we have this registering on our eyeballs and it's not super awful and blinking. Now unfortunately, so 1000 over 50. So we are limiting ourselves to 20 frames per second. But that's okay for the moment. Is that right? 20 frames. Yeah, 20 frames. 20 frames per second. But now we need to do something about, hey, when the player and the location are the same, do something about it. So process input, and that's part of process input. And really let new player position equal that awful, atrocious thing. Let's call it new player. And if new player equal board state dot dollar, well, and how do we do this? And eat dollar. Board state's going to eat the dollar, which is really we're going to check to see if we eat the dollar. Let eat dollar board state equal board state. So we start out with it doing nothing, so but at least board structure. So, but at least it compiles. And what we want to do here is so we've already got the player's already up to date. So if board state dot player equal board state dot dollar, then else. So when that happens, I want a couple of things to go on. I want board state with dollar equal random board position and score, which we haven't done anything yet. Board state dot score plus 1. We're going to increment the score, and hey, while we're at it, why don't we render the console dot cursor left equals what's it called? Board columns. Console dot cursor top is 0. And again, I'm too imperative. I need to be less imperative. So console dot right we got the board state score as printf %I, and that's all we really need. Gonna write the score right up there. We've already cleared the thing. We're doing it every 50 milliseconds, and we will eat the dollar and move it along. Let's see if it works. There's my score. Do I eat it? And yay! I've got a game in just under an hour. Yep, and you can do this all day. Currently can't quit the thing other than, well, you can close the window, but here it is. And you can eat the monies. And hey, that's a playable thing. So, and this is as good a time as any to end the episode. There will be a GitHub release with this current state of where we are. You can get it. You can play with it. And that's However, I just want to go over real quick. This is not very safe. If you go off of the screen, I'm here on the left edge. I hit go left, and I have explosions here. So you've been warned if you decide to bring the thing down. But hey, it's a cool thing. We got a game going, and it's something we can build off of, and something that we can make into something pretty awesome. And then we'll bring it to mono game so that we can have some real graphics. But hey, thanks for joining me for this very first episode of The Joy of Functional Game Dev. Please join me next time where we're going to continue on and get some checks in there, get a game over, get a timer, and some other cool stuff as much as we can in about an hour. And other than that, thanks so much for watching. You have been watching the exciting first episode of The Joy of Functional Game Dev with Ernest Pizzera. Hopefully next time a better announcer will be found so that the host doesn't have to do this. If you like this video and like to see more like it, please like and subscribe, and you can always visit the Patreon page listed in the description below. This has been your announcer,